What's up? Welcome back to my channel. I'm going to be doing a really quick unit review of Unit 2. And Unit 2 is basically quadratics, imaginary numbers, and combining the two. So we're going to get started. Okay, so first problem would be factoring. So let's say I have q squared minus 11q plus 24. And if you haven't watched my videos on how to factor, go watch my video on that, so it'll be easier to understand if you don't understand it this time. So what you want to do is you want to figure out what two numbers multiply to get your C term and what add to get your B term. So what multiplies to get 24 and adds to get negative 11. And it's going to turn out to be 8, negative 8, and negative 3. So you put those factors in, q minus 8, q minus 3. Okay, but if it says to solve, let's say it had a equal 0, and it says to solve, we just set each to equal to 0. It's going to be q equals 8, q equals 3. A is not equal to 1. So let's say we have 4x squared minus 6x minus 18. Alright, so the first things first, with all quadratics, you want to find the GCF. And for this example, it's 2. So 2x squared minus 3x minus 9. That's the GCF version of it. So now you want to go ahead and do our box. So this turns out to be 2x minus 3, x minus 3. So that would be our factored form right here. If this is equal to 0 and wants us to solve, we would just simply equal these to 0. So this would become x equals 3. This would become x equals negative 3 halves. So let's say you had x squared minus 49. So what you would want to do is you want to take the square root of each term. So what's the square root of x is x, and the square root of 49 is 7. So you would use x and just leave the blank for right now, x, 7, and do the same thing for the second set of parentheses. And for the first one, you'll put a plus sign, and the second one, you put a minus sign. And just like that, we're done. So x squared minus 49 factored is x plus 7, x minus 7. X squared minus 361. How would that be factored? You take the square root of the first term, which is x, and the square root of the second term, which is 19. And you put the plus sign in the first set and the minus sign in the second set. And this difference of squares only works if you have a minus sign right here. If it's a plus sign, it will not work. And I'll show you an example of that, like right here. So let's see, you have x to the 4th minus 81. So you want to take the square root of the first term, x squared, and the square root of the second term, which is 9. So you have x squared plus 9, x squared minus 9. And if you were to leave this as your factored form, this would be wrong, because if you look at the second set over here, this is another difference of squares, because x squared can be square rooted and the 9 can be square rooted. We do not want to do the first set because it's a plus sign. We can never do a difference of square if it has a plus sign, only if it has a minus sign. So you want to keep the first set the same, and you want to factor the second one as from difference of squares. So x plus 3 and x minus 3. And the way I do all the difference of squares is by taking the square root. Quadratic formula is negative b plus or minus b squared minus 4ac over 2a. So the first things first is to simplify all the like terms. So I want to subtract this 2x over, so it will be x squared, subtract this 3x plus 3x, my bad. And then we're going to move this 4 to the left side. So plus 4 equals 0. So now we can use the quadratic formula here. And so in some cases, if you type this into the calculator, it's going to work. But sometimes it's going to come up as domain error. And every time it comes up as domain error, you have to work it out like by hand. And because, I'll show you why. Okay, so if we keep working this out, we're going to have negative 3 plus or minus the square root of 9 minus 16 over 2. And this is going to be equal to a negative 3 plus or minus the square root of negative 7 over 2. So anytime you have a negative radicand, a radicand is the number underneath the radical. So anytime you have a negative radicand, you cannot have that. So you have to do something called imaginary numbers. Alright, so you have negative 3 plus or minus, and I is going to come out. I square root 7 over 2. And I just refers to the square root of -1. That's why it comes up as domain error, because the calculators don't have I in their system, right? So we just have to put square root of -1 represents I. So this right here would be your answer. Let me just write I equals square root of -1. So let's say we have x squared equals to -49. So now think about this. If x was equal to positive 49, we would easily know that x is plus or minus 7. But right now we have a -49. So what we want to do is going to put x equals plus or minus 7i. Because that I represents that -1, the square root of -1. X squared equals 169. And that would be -169. X would equal plus or minus 13i. So the first thing we're going to want to do is take the square root of both. So we have x minus 3 here equals the square root of -12. And this goes back to that I thing. So anytime you have a negative radicand, you have to put I. So this will become, well, first, before I do that, 12 can be simplified as a radical. So if we had regular 12, this could be split up into 4 times 3, take the square root of that, so this becomes 2 radical 3. So x minus 3 equals plus or minus 2i radical 3. Because of this negative right here, it's going to go after the coefficient right here. So it becomes 2i radical 3. And this one's kind of hard to explain because you have to know how to simplify radicals in the first place. If you don't remember how to do that, then it's going to be kind of hard. But yeah, so then you just want to move the 3 over. So 3 plus or minus 2i square root of 3, and that's your answer right there. All right, this would be the same thing. You do the box method and get your terms. So 2 plus 3i minus 20i squared will become positive 20. And so now we'll put 22 plus 3i, and that's our answer. And always make sure the format is an a plus bi, and the imaginary comes after. Conjugate. Solve by taking the conjugate, right? So 2 minus 5, and the conjugate is just flipping the sign, right? So if it's only the denominator. So if it's 2 plus 5i, it's going to be multiplied by 2 minus 5i. And we're going to just keep on going. And a little trick I use is if you just square this, 2 squared is equal to 4. Then you square this, 5 squared is equal to 25. Add them together, 29. Boom, that's your denominator. That's the trick I use. So we don't even have to use the box method. We already have the denominator. So now we can use the box method for the top. 2 minus 11i plus 15i squared. 2 minus 11i plus 15 negative 1. 2 minus 11i minus 15. I'm just doing all this steps to make sure you know how I'm doing this, and that's going to be your answer right here. Well, actually, no, that's going to be your factored form, so we're going to put it back up here. Negative 13 minus 11i. And so now, once you figured out the top term and the bottom term, you want to split them. So it's going to become negative 13 over 29 minus 11 over 29i. Find the absolute value of 5 minus 12i. So what we want to do is basically Pythagorean theorem. You would take the first term and square it. So 5 squared plus, take the second term, negative 12 and squared. And that's going to equal our c term. So 25 plus 144 equals c squared. 169 equals c squared. And that equals 13 equals c. And always take the positive. So basically, to find the discriminant, it's b squared minus 4ac. So it's negative 6 squared minus 4 times 3 times 8. So 36 minus 96, which equals negative 60. And so our discriminant is negative 60, which means it has 2 imaginary numbers. Okay, and so in order to determine how many solutions it has, if it's positive, it has 2 real numbers. If it's 0, it has 1 real number. And if it's negative, like above, it has 2 imaginary numbers. All right. So hopefully this was a quick rundown of the whole of Unit 2. So hopefully this helped. And yeah, good luck on the test.